Good morning, class. I'm Ashish. I'm a chemical engineer who's enthralled with physics, and today's class will be studying physics. So today's class is on Doppler's effect, and Doppler effect is a phenomena in physics that deals with observed frequency of a sound wave. And what happens in Doppler effect is there is an observed change in relative frequency of a sound wave due to relative motion of source, observer, or both. So in today's class outline will be what is this effect, right? So what is this effect? What is the underlying source of this effect? What are key formulas that we need in this effect to target problems in MCAT at a reasonable speed? And the final thing is, what are some key real-life applications? Real-life applications, right? So first, what is Doppler's effect? So Doppler's effect is relative change in observed frequency, of sound waves due to motion of the source, observer, or both. And to explain this better, I would have to throw some questions at you. So how often has it happened in your life that you were driving and then you have to pull over because an ambulance is approaching? And what were your observations when when you first observed the ambulance, when it's approaching you and when it's receding away from you? Anyone in the class? Jen?
Yeah, so when the ambulance was far away from me, I observed that the sound was not that high, but when it approached me, I felt that the sound was louder. Is that correct?
Alright, so that is reasonable. So what Jen is saying is that when the ambulance was approaching, she was hearing a louder sound. What really happens is that you are hearing a higher pitch when the ambulance is approaching. And when the ambulance is receding, we hear a lower pitch. Now what is pitch? Pitch is related to the frequency of the sound waves, or the frequency of the sound waves hitting our eardrums. And to explain this all in more detail, I would have to have a fun example. So imagine you are heading for a weekend getaway in Lake Louise. All right. So this is Lake Louise. The water is still; there is no current, and in the middle of the lake, you are in a boat. All right. Some distance away from your boat is a bird. The bird is also is just sitting on the surface of the lake. It's not swimming. And now the bird starts flapping its wings. All right. The bird starts flapping its wings. It disturbs the air around it. It generates a wave. So now these waves, so if this is the bird, these waves, will travel in all directions. All right. So this is the waves. All right. So what are these lines? So these lines represent the crest of the waves. All right. Right. And the reason these lines are equidistant is because waves move in all directions with same speed. So you see these wave fronts are equidistant. All right. Now this is you on the boat. This is the bird. So what you will observe is a set frequency of the sound wave. All right. Now imagine this bird now starts swimming towards you. All right. So now this bird starts swimming towards you. All right. So of course, once this bird starts swimming towards you, these wave fronts will change. All right. So these wave fronts will change once the bird starts swimming to you. The new wave fronts will look like this. So you see, if this is the observer and this is the source, now these wave fronts, there is less gap between these wave fronts. They will hit your eardrum at more frequently in less time intervals. So what you will observe is a higher pitch. The same thing happens in the case of the ambulance. The ambulance is moving towards you, and the sound waves produced by the siren, they hit your eardrums more frequently. You observe a higher pitch or a higher frequency wave. Is that right, Jen? Does that explain the phenomena better?
Yeah, that makes total sense.
Okay, alright, so now what are the key problems that will come in this phenomenon? And MCAT, we have to solve as many problems as we can in as little time as possible. All right. So there are two key formulas in Doppler's effect. Two scenarios. Okay. Once when the source is moving, and one when the observer is moving. All right. So we all know that the speed of sound in air is about 340 meter per second. All right. So this is speed of sound. All right. 340 meter per second. V minus V source. So if the source is moving towards the observer, all right, this is the speed that you will